Hi guys, so this is another very good lecture we are going to start today, which is solar cell. So you guys may wonder, when we are using solar cell, we are able to get some current and electricity from that. But as an engineer, we have to wonder how the things is happening. So as an easy engineer, so we will be getting a good idea to here to look at how the things is working. So before we know, in a diode, when we give a forward bias potential to that, the more excess number of volts will be injected as an minority charge carrier injection or majority charge carrier injection, which is low level injection will happen, and the depletion region will decrease and current will flow. Some recombination will happen. Based on that, the LED will blink. Here, if you see, this is a photovoltaic cell or a solar cell. So whenever there is an incident of light is happening, whenever the h nu which is greater than the band gap as discussed in semiconductor device basis, more number of charge carriers will be get generated here. So holes will be generated because of that. Here electrons will be generated because of this. So because of this excess charge carrier generation, this will diffuse through this way. So electron will diffuse through this way and electrons will diffuse through this way. So this will make the current to flow, which is IL, which will flow and which will make this bulb to glow. So when we connect a bulb or if a generator is connected, it will store energy or it will glow. So this is how the thing it will act. But this PN junction, which will not be as similar like how the normal PN junction that we are using. The thickness of both the P and N region should be very small. So now the condition is that the thickness need to be very small. Okay, so doping of P and N need to be heavy. So these two conditions are needed to make the junction into solar cell. So IL, which is optically generated current. Okay. So I hope you guys able to get some point in solar cell. So let's get into the stuffs like INET. So INET is nothing but which is the total current that will be flowing through the stuff things. So here two types of current that they are mentioning. One is IL. So IL which will be flowing in the this circuit. So IL is the current that is flowing in this circuit. But there is another one current that is IF. So IF which will also be flowing in the circuit, that is where is because of some inbuilt potential difference will be take place. So because of that, some resistivity or some opposite that current will flow, that is IF. So this IF we have to be take care of it. So this IF which will be negligible, very small only, so that we need to be not to be worry about, because every time the charge carrier generation will not be in this direction only. Some holes will also be generated here. So that will move in this direction. Some electron will move in this direction. So because of that, the IF will also be generated. So because of that, so I net will be IL minus IF. Okay. So this IF, the IL is the majority charge carrier current. So that is equal to IL. The IF can be written as I naught e power V by eta Vt. So which will be similar to the diode current. So diode current equation we are applying, because in this case if you see, this is the normal thing, like if we connect a battery to this, the current will flow in this direction, that is ID, which is with diode current. So the ID which is similar to IF, so we are used to the diode equation current here. So I hope this is understood for you guys. So let's take this as a equation 1. So something we are going to analyze in this equation. First thing is the short circuit potential, short circuit current. So ISC. So ISC is the short circuit current. The condition for the ISC to exist is the RL need to be 0. Let me draw a circuit so that you guys able to understand it. RL is nothing but the load which will be connected here. So let me draw the solar cell so that you guys will be able to get it. So if you take the case, this will be the solar cell. So this is charge carrier separation. So lastly we connected a bulb, right? So instead of bulb, we are going to consider the resistance here. So that is R. That is RL. Okay. So here two current will flow. Here there is IF similar to the diode, and the majority of IL because of the generation. So this is P This is N. Okay, so I hope this is understood. So if RL which is equal to 0, then we can note that we may know that V will also be equal to 0, because V is the potential that is taken in this way, V across RL. So then V will also be equal to 0. So if V is equal to 0, then we can relate in that equation that because of that the short circuit current IF, that will be equal to I naught e power V by eta Vt minus 1, that will also be equal to 0, because this is a diode current equation that is flowing across this R. But once they take the condition, then that will also be equal to 0. So the short circuit current ISC, which will be directly equal to IL. Okay, so this is one kind of observation that we are taking into picture. The second thing is the open circuit potential. Open circuit voltage or potential. So that we represent as VOC. So in order to find VOC, we take a condition RL which is equal to infinity. If RL which is equal to infinity, the circuit is open, so the net current flow will also be equal to 0. So if the net current flow which is all equal to 0, then I net will be equalized to 0. Then IL which will be equal to I naught e power eta Vt V divided by eta Vt minus 1. Okay. So if we bring this minus 1 to this side, then that will be IL plus I naught, which is equal to I naught e power V divided by eta Vt. So this IL plus I naught, which can be divided by this I naught. If we divide this by I naught, then e power V divided by eta Vt, which is equal to IL plus I naught divided by I naught. So if we divide this further, 1 divided by I naught divided by IL. So if we take a ln over this, VOC which will be equal to eta Vt ln 1 plus IL divided by I naught. Okay. So I hope you guys able to, I think I made a mistake here. So which is IL divided by I naught. So IL I naught. Okay. So this is the short circuit. This is because of the VOC, which is short circuit voltage, open circuit voltage. The IL here it is, right. So this will be also equal to ISC. Okay. So this is same. So this is how the some kind of characteristic that we can take into picture. So let's compare the solar cell characteristic, VI characteristic curve. So let's take three different things like a photodiode, how the characteristic curve will be for photodiode and all the things is. So this is the characteristic curve for photodiode. So this is characteristic of solar cell. Okay, so let's draw it. So everything is VI graph only. So V, I. So in photovoltaic diode, it will be similar to the normal junction diode. So based upon this thing, the current potential will vary. Let me draw it simply. So this is how the potential. If it is starting from 0 here, then it will go like this way. So this is normal photodiode. So based on some kind of condition, the threshold, the starting value will be based on the material thing. So this is for photodiode. For solar cell, it will be quite different. It will start from here and it will end at here. So the VI characteristic curve will be like this one. So the IL will be directly proportional to intensity of light. Okay, so the graph will be quite similar to this one. So these are all the condition that we can take. So here some criteria we can take and match it. So similar to the operating point that where we have took. So here also there will be some operating point. That will be VM and IM, which will be the max. At this point of thing, we can take, this will be P max. So at this point only power will be maximum. So that similar point is IM divided by VM. So the PM which will be equal to IM into VM. Okay, so this is the max power that we can take it. So this point, this is ISC, and this point which is VOC. This is open circuit potential where the IH is equal to 0 or R which is equal to infinity. Here the R which is will be equal to 0. So the P will also be equal to 0. Here P will be equal to infinity. Sorry, P here also will be equal to 0 watt. Okay, so at this point only power will be maximum in the solar cell. So that is the operating point that we need to choose when we are doing any kind of things. So some kind of inbuilt parameters are there in order to define a solar cell characteristics. So that are the different things like film factor. Second one is the conservation efficiency. Third one is quantum efficiency, which is Q efficiency. Fourth one is responsivity. So these are four fundamental parameters that we need this data or this kind of data sheet to represent the solar cell characteristics or behavior. So in the next class we'll be seeing this one. So I hope in this lecture the solar cell, how the solar cell functionality is coming into picture, you guys able to get some idea I think. So please like, share and subscribe the channel. So stay tuned for the next lectures.